Today is all about isotopes. So we're going to cover all these things in a series of videos. I just want to get cracking. All these are on the master document. So we're going to start here. There's a lot of terminology and stuff in here that I'm again going to kind of rush through because you can get that from your reading. So the number of protons determines the identity of an atom. Okay? It's so important that it's given a special name. It is the atomic number, and that has the symbol Z. Okay? So let's look at our periodic table, and here I see atomic number is this number in the periodic table. And if you're looking closely, you can see that the periodic table is actually arranged in terms of increasing atomic number. So it is actually very important, okay? So for example, hydrogen has an atomic number of 1. Helium has an atomic number of 2. Lithium has an atomic number of 3, okay? So one thing to keep in mind is that, let's say that I have boron. Boron has 5 protons in it because its atomic number is 5. Okay? That's boron right there. If I add a proton, okay, which you can't do, but if I could add a proton, it's not that I would like change the charge, make an ion, make a different isotope. No. I would change the element. I would be carbon now, okay? And then that would change all the properties. So, atomic number, very important. Hydrogen has the atomic number 1, okay? However, all atoms of hydrogen are not the same. What? They all have 1 proton, okay? Well, let's talk about that. There are actually 3 different kinds of hydrogen atoms, and we're going to use these. We're going to use hydrogens as kind of a model system to talk about what's going on. All right. So let me run through this and I'll come back. Protium. Okay, this thing has a name. Protium. The nucleus of protium has only 1 proton. Okay, and oh, by the way, 99.9885% of all hydrogen atoms are protium, meaning the nucleus has only 1 proton. Okay? Deuterium. Well, now, okay, the nucleus still has to have 1 proton or it's not hydrogen anymore, but now the nucleus also has 1 neutron. And this makes up 0.0115% of all hydrogen atoms. Now, if you add up those numbers, that adds up to 100%, okay? So I said that there was a third one, but the third one, you already know, makes up such a small fraction that it doesn't even show up out to 5 sig figs, okay? Tritium, the nucleus has 1 proton and 2 neutrons, and the addition of that extra neutron actually makes it unstable, and it's radioactive, meaning it decomposes into something else, okay? So all of these are called isotopes, okay? They're atoms of the same element that have different masses, okay? Atoms of the same element have different masses. Now, not all isotopes have names like protium, deuterium, tritium. We're going to get to that, okay? But for hydrogen, they do have names, and I don't expect you to remember them, but they might be good to know later. All atoms, notice all caps here, I'm going to like highlight this because it's pretty important. All atoms of an element have the same number of electrons as protons, okay? That is also important to remember. So if I have hydrogen, okay, if I have hydrogen, I know that hydrogen has 1 proton. So an atom of hydrogen must also have 1 electron. Okay, now Let's talk a little bit about symbols for these things, because that's going to help us speed through this a little bit. A proton has a positive charge, you know, so it's actually, the symbol for proton is P+. Electron is E-, and neutron is N0, doesn't have a charge, okay? So the only thing that changes in an isotope is the number of neutrons, N0. Okay. Now, the kind of cool thing here is that isotopes do not differ significantly in chemical behavior. They do differ a little bit, but protium and deuterium will act very similarly, okay? Because they have the same number of protons, they have the same number of electrons. The only way that they differ is the number of neutrons, okay? And you'll see the term nuclide used a lot. And a nuclide is just a general, generic term used for an isotope. You can use them somewhat interchangeably. Okay? So, identifying isotopes. Like I said, not all isotopes have names, and that's a good thing, because protium, deuterium, tritium, if all elements had that, remembering even what we were talking about would be a complete and utter disaster. Okay? So, I want you to think in your head, in order to identify an isotope, what do you need to know? Okay? What two things do you need to know? Well, in order to identify an isotope, you need to know the name of the element and the mass of the isotope. Now, a lot of people think, oh, well, you need to know how many protons and how many neutrons there are. Okay? Well, these things are very small. It's impossible to know how many protons and how many neutrons, because you can't count those things. Okay? But you can get a mass. If you have a sample, you can get a mass of the isotope, and you can know the element, and that you can use to identify isotopes. Okay? So we use this thing called mass number. All right? Mass number is the total number of protons and neutrons that make up the nucleus of an isotope. Okay? So that's protons plus neutrons equals mass number. Okay, so this is a diagram from your textbook, and we're actually going to fill it in. Okay, let's just what was the atomic number again? Oh, right. That was the number of protons. Okay, and what was the mass number again? That was the number of protons plus neutrons. Okay, so here's our table, and we're going to fill in some numbers. So, what is the atomic number of protium? Well, how many protons does it have? By the way, you should pause this here and see if you can fill out this table, and then see if you get it right. So I know that all of these things actually have the same atomic number, because they all have the same number of protons, because they're all isotopes of hydrogen. They each have one proton. Okay, now if I remember back, protium only had one proton in the nucleus, so it had no neutrons. Okay, so its mass number was 1 proton plus 0 neutrons equals 1. That's the mass number. Okay, deuterium, I said, had 1 proton and 1 neutron, which means that it has a mass number of 2. Okay, and tritium has 1 proton, 2 neutrons, so it has a mass number of 3. Okay, now notice that if I need to find, like, for instance, the number of neutrons, okay, I can use the mass number and subtract the atomic number. So if I have the mass number of deuterium, okay, which is the number of protons and the number of neutrons, and I subtract the atomic number, I get 1 neutron. Okay, so I can use these things to figure out different pieces of the atomic puzzle. okay? And I'll be asking you to figure out simple things like this as we go on. Okay? So there are generally two methods for identifying isotopes. There's the hyphen notation, and there's the symbol notation. Hyphen notation, GASP, uses a hyphen, and symbol notation uses GASP, the symbol, the elemental symbol, okay? So let's roll through what these things are going to look like, okay? So hyphen notation, you use the name of the element hyphen the mass number, okay? So let's say that I have sodium, okay? And let's go to my handy dandy periodic table. Here's sodium over here. All right, sodium, there's sodium right down there. Okay, sodium has a mass number of 11. So, or sorry, an atomic number of 11. So it has 11 protons. So let's say that this isotope has 12 neutrons. Okay, so the first thing that I want you to think about is, how many electrons does this isotope have? Well, because this is an atom, it's an isotope, but it's an atom, the number of electrons I have is the same as the number of protons. Okay, now this won't be the case only when you have an ion, okay, which we'll talk about later. So this is Na with 11 protons, 11 electrons, and 12 neutrons. So the hyphen notation would be written sodium hyphen the mass number. And remember, mass number is the number of protons plus the number of neutrons. So this is 11 plus 12, which is 23. What am I doing? Sodium hyphen 23. So the hyphen notation of this isotope would be sodium 23. All right, so quickly, see if you can write the hyphen notation for the isotope of K with 20 neutrons. All right, so pause and see if you can do that and check. All right, so I'm going to look at my periodic table. Okay. K is potassium, and it has an atomic number of 19. So 19 neutrons, or 19 protons, plus 20 neutrons gives 39 is my mass number. Okay? So my hyphen notation would be potassium 39. Okay? So that is hyphen notation. Well, what about symbol notation? All right. So uranium-235 is used in nuclear power plants. That's the fuel for nuclear power. Okay? And there is its symbol notation. Okay. So if we thought about this, let's use the periodic table, shall we, and see if we can figure some stuff out. Well, uranium isn't up here, it's actually down in the bottom. It's in the actinoids. Okay. Ah, look. The atomic number of uranium is 92. And this number down here is 92. So this must be the atomic number, or Z. Okay, now so we know that uranium-235, we know that this is the mass number. Okay, because that's how hyphen notation works. So we know that this is also mass number. And this is just the element symbol. Okay, so one thing that I'm going to be picky about when we have the test is hyphen notation. You cannot write this as U235, okay? Hyphen notation has the name not the symbol. This is sort of a hybrid that we don't like, okay? If you're going to go symbol notation, it needs to have the mass number on top and the atomic number on bottom. Now, the easy way to keep this in mind is that the mass number is always going to be equal or greater than the atomic number. So the bottom should be smaller than the top, okay? So now, how about a challenge question? How many neutrons are in this element? Well, we have the mass number. Pause. See if you can figure this out. And then check. Okay? We have the mass number, which is the number of protons plus the number of neutrons. And we have the atomic number, which is the number of protons. So we can just subtract those two. 235 minus 92 equals 143. And that's how many neutrons I have. Okay? So now I'm just going to have you start doing some sample problems. Okay?